Greetings, students. Let's discuss practice test 3-3 for geometry. Let's begin. Question 1. So here we're looking at each interior angle. So we take 180 times by the number of triangles to get the sum of the interior angles. So 180 times by 11 is 1,980. That would be the angle sum. We're going to divide that angle sum by 13. The number of angles and the 13 gone. So we divide that by 13. We get about 152.3. It says to round to the nearest tenth. Next question. Exterior angles. The exterior angle sum is always 360. Each exterior angle, we're going to divide 360 by the number of sides or angles, which is the same as the number of sides. 360 divided by 21 is about 17 and 1/10. Solve for x. These will be equal. Take 7 away from 147, and then divide by 28. It's 5. Again, you can use the calculator to assist you on all these questions, so just we'll use it. All right, next one, CM and ME. CM and ME are equal because on a parallelogram, the diagonals are bisected. So I will set these two equal to each other. 3x plus 4 is equal to 2x plus 9. 2 from 3x is x. 4 from 9 is 5. Alright, next one, mid-segment. 10x minus 3 is equal to, we're going to add these two and divide by 2. Half of 20 plus 14. So half of 20 plus 14, that's 34. Half of that is 17. 10x minus 3 is equal to 17, in other words. Add 3 to 17, you get 20. 10 into 20 is 2. This one is the same deal. We might want to, instead of taking half of these two added together, double this one, because you can double the right side. But we'll set it up the same way. So the mid-segment, 21, is equal to 1/2 of the sum of the bases. 17 minus 2 plus 3x. So again, I might want to just double the left side here instead of taking half of these odd numbers. So that's what I'll do here. I'll make that 21 into a 42. And then 17 minus 2 is 15 plus 3x. 15 from 42 is 27. And 3 into 27 is 9. So the setup's the same here on both these. Half of the sum of the bases is equal to the mid-segment. Mid-segment, 21 there. Mid-segment's 10x minus 3 there. Equal to half of the two bases, the top and the bottom of the trapezoid, added together. Here I doubled the left because it's easier to double the single number than it is to take half of both these odd numbers. Here I took half of the number inside because it's easy to take half of these. 10 plus 7 is 17. Anyways, isosceles trapezoid. They have the base angles congruent. So 9x minus 24 will equal 75 here. 24 and 75 is 99. 9 and the 99 is 11. Alright, isosceles trapezoid here as well. The diagonals will be congruent on an isosceles trapezoid. So WU is equal to VT. or VT equals WU. 4x minus 23 equals 21, in other words. 23 and 21 is 44. 4 into 44 is 11. X is 11 here as well. Alright, kites. So if ABC is 84, angle ABC, that means angles 2 and 3 are both 42s. So angle 3 is a 42. If AD3 is 52, that means 8 and 9 are both half of that. 26. 26 and 26 for 8 and 9. Alright, 6 and 7 are both going to be the supplement of 26, which is 64. 1 and 5 are both going to be the supplement of 42, which is 48. And the angle in the middle is always 90 on a kite because the diagonals are perpendicular. And there we go. Alright, Pythagorean theorem. Again, you're deciding whether to add or subtract. So put the bigger number first, put the smaller number second. If you're looking for the longer side, the hypotenuse, you're going to add. Sorry. 8 squared plus 6 squared is 100. So my answer is the square root of 100. Which is 10. So it did say to round your answer to the 10th. We are going to type it in the calculator this time. Square root of 100, 10. This one, 9.2 squared, 4.1 squared. Here we're looking for a leg. We're not looking for the hypotenuse. The hypotenuse is always opposite the right angle, or it's the longest side. So because we're looking for a leg, we are subtracting here this time. Here we're looking for a hypotenuse. We're adding. Here we're looking for a leg. Subtracting. Always squaring the sides. Decide whether to add or subtract based on if you're looking for a leg. Subtract. Hypotenuse. Add. For Pythagorean theorem. 9 and 2/10 squared minus 4 and 1/10 squared. That's 67 and 83/100. So x is the square root of that. You need to be able to find the square root key. It's above the squared key. Square root 67.83. That's about 8.2. Round to the nearest tenth. Alright. Acute, obtuse, or right. So here I'm going to take the two shorter sides, square them and add them. 12 squared plus 12 squared. Compare that with the longest side, squared, and I'm going to see what's bigger. 12 squared plus 12 squared. That's 288. 288. 15 squared. 225. So 288 is bigger than 225, which means my triangle is acute because the legs are bigger than the hypotenuse. Same thing here. Take 5 squared, add 12 squared, see what you get. 5 squared plus 12 squared. It's 169. What is 13 squared? Not 13, 13 squared. It's also 169. These are equal. That is a right triangle. See, for it to be obtuse, the legs would have to be smaller than the hypotenuse when they're squared and added. So instead of being both 12s, if one of these was a 8, that would work. Because then it'd be less. 64 plus 144 is 208. Anyhow, so there's the front. 18 questions on the front. We got 10 on the back. So let's move on. Question 19. This is the unit triangle, 45, 45, 90. It's got congruent legs. And the hypotenuse is the root 2 part of this, so these are both 8s. N is equal to M, and they're both 8. Because these legs are congruent. This is the 30-60 triangle. The short leg is half of the hypotenuse, and the long leg is the short leg times pi root 3. There you go. I have the unit triangles on the board for you. You just have to be able to match them up and have to be able to figure out what it means. Again, the ratios are x, x, and x root 2. And this is x, 2x, and x root 3. That's the ratios. Or you could think of it as blank, blank, blank root 2, blank, 2 times blank, and blank root 3. However makes better sense to you. Alright. Next thing, this. So that's 25. That's 16. This is the what should I call it? The ratio questions that we haven't gotten to yet. But I'll see if I can get them right for you. So this, I'm going to subtract 16 and 25, and I'm going to get 9. I don't really want this hypotenuse here, because I don't have the hypotenuse on this triangle labeled or the hypotenuse on this one. So I prefer, instead of a 16 and a 25, I'd prefer to have a 9. I'd much prefer to have that 9. Alright, so on this triangle, the top one, short side is x, long side is 16. I shouldn't say short and long, I should say short leg, long leg. We don't have the hypotenuse labeled. On this triangle, the short leg is 9. The long leg is x. So there's our setup. We're going to cross multiply to solve it. X times x is x squared. 9 times 16. I can use a calculator if I want to. I don't really actually have to multiply that because I'm going to square root it in the end anyways. But if I did, I'd get 144. X is 12. Now x is not negative 12 here because lengths cannot be negative. If this was an algebra 2 question without a picture, set up like this, we'd have positive and negative 12. But here in geometry, we got a picture. This length can't be negative. Positive 12 is the only answer here. Now what we got here? We got 16, we got 9, we got x. So here, I would much like a hypotenuse. I would like a hypotenuse here because I've got a hypotenuse labeled with x. I'm going to take here and I'm going to label this as 25. Why? Because on this short triangle I've got 9 as a leg and x is a hypotenuse. So x is the hypotenuse and 9 is the short leg on this right triangle here. And then on the big triangle I've got x as the short leg and 25 as the hypotenuse. So there's my setup there. Again, I don't really have to multiply this because I'm going to square root it in the end anyways, and I can square the numbers separately. But if I'd like to use a calculator to multiply, I can. 9 times 25 is 225, which is square rooted to make 15. 225, not 22. There we go. Again, that answer is only positive because we're looking at lengths. Lengths cannot be negative. This is a length that can't be negative 15. Alright, so I picked some harder setups there with those two from our unit. Just remember you're taking short leg, hypotenuse, or short leg, long leg, short leg, long leg. You're making the same things on the top. So if this one I did short leg, long leg, short leg, long leg. This one I did hypotenuse, short leg, hypotenuse, short leg. And that'll help you remember these hopefully. Next one, tangent. SOHCAHTOA is what we have for the acronym. SOHCAHTOA. I'm not going to give you that acronym on the board. Memorize that. So tangent is O and A. O is opposite, A is adjacent. Tangent is equal to O opposite adjacent ratio. So opposite from C, across from C is 20, and adjacent is 21. So I always draw an arrow to the opposite side. That helps me remember which side's opposite. The hypotenuse is easy because it's the longest. So the opposite from C is 20. Cosine, ca. This is adjacent hypotenuse. Adjacent hypotenuse. So here's A. This side is opposite. There was C. Opposite is 20. Here's A. Opposite is 36. The side not connected to the angle is opposite from it. These two sides are connected. CA and AB are connected to A. 36, CB is not connected, so that's opposite. So I want adjacent hypotenuse. Adjacent is 15 because the hypotenuse is 39. 39 is the longest. That's how I identify the hypotenuse. And again, the adjacent is the side that's not opposite. Alright, sine of C, so opposite hypotenuse. So here's C, the side opposite is 12. And then the longest side is 20. Well, that one reduces. Actually, the last one reduces as well. So if you want to reduce those and give me reduced answers, like it says in the work up above, this one would divide by 4, become 3/5. This one would divide by 3, becomes 5/13, in reduced format. Alright, and then the last group of 3, these are also SOHCAHTOA. What I'm going to do is identify the trig ratio used with the given angle. So here's 56. This is opposite from 56. This one's the hypotenuse. So what I have is opposite hypotenuse labeled. Opposite hypotenuse, which is SOHCAH, which is sine. So I'm going to use sine of 56 equals 14 over x. As we discussed before, because x is on the bottom here, you're going to be dividing 14 in the sine of 56. These two switch spots, in other words. 14 divided by sine 56. They switch spots. And the reason they switch spots because you get times by x and then divide by sine of 56. Alright, so we got 14 divided by sine of 56. We got about 16 and 9/10. 16 and 9/10. To check your work here a little bit, it's very difficult to actually check your work exceptionally well, but to check work a little bit, x is longer than 14 because x is the hypotenuse here. So I should expect an answer bigger than 14. Alright, so here's 66. This is opposite. So I have opposite. This would be the hypotenuse because it's across from the 90. So I have opposite adjacent. I have tangent, TOA. I'm going to do tangent 66 is equal to 10 over x. Again, because x is on the bottom, you're going to be dividing here. 10 divided by tangent 66. It's about 4. 4.45, so 4.5 about. Again, we can check our work a little bit here based on the sides labels. So 66, this angle is bigger than this angle. Also, this side 10 is bigger than x. 10 is, it looks like it's about twice as long as x, so this makes sense that it's 4.5. The pictures are somewhat to scale, not exactly to scale. So yes, x is about 4.5. That makes sense. It's less than 10, in other words, because 66 is bigger than this angle here, which would be 24. 90 minus 66, in other words. Now this is also tangent, because we have the opposite side there labeled as 60 as 12, opposite from 63. So we'll do TOA here as well. We got opposite, adjacent. So I got the tangent of, what was that, 63? Yeah, that's 63. Sorry, I kind of drew over it when I wrote it. Tangent 63 equals 12 over x. That is a 6, isn't it? Yeah, it's a 6. So here again, I'm going to divide I didn't end up doing any of these where I multiplied, but if the numbers on the bottom you end up multiplying, let's keep that in mind. I might have that on the test instead of having the division one, because not all of these end up dividing the number by the tangent or sine or cosine. Just depends on the setup. In other words, if the x was here, I would end up timesing by 12 instead of dividing it. So 12 divided by the tangent 63, it's about 6.1. And again, we can check our work a little bit. This side 12 looks to be about twice the length here of the x, so it makes sense, 6.1. And you can look at it and visually and you can see, yeah, it's about twice as long as x. That's part of geometry that you should be learning. Anyways, good luck. Hopefully you do well.